In this video we are going to learn how to draw the figure that is displayed to you. So this video is made specifically for mathematics teachers who face difficulties in using Microsoft Word to draw figures, especially when they are setting questions. That's why I'm doing this video. Nevertheless, at the end of this video we are also going to see how to solve the problem, but maybe I'm going to push the solution to another video. Okay, alright, so this question is basically from the Littoral mock of 2023 Pure Maths with Mechanics paper 3, and it is question 4. The question reads: figure 2 above shows a particle of mass m on a smooth horizontal plane connected by the means of a light inextensible string to another particle b of mass 2m, which is on a rough plane inclined at an angle of 60 degrees to the horizontal. The coefficient of friction between B and the plane is 0.2. The system is released from rest with the string taut. Now here is a figure that has been displayed. Now you have the first question is asking us to find the acceleration of the system. Second question is asking us to find the tension in the string, and the last question is asking us to find the force exerted at the pulley. Alright, so like I said, this video I'm going to concentrate on just actually maybe typing the question and drawing the diagram, and then now in the next video we are going to see how to solve the problem. Alright, so to do this, like I said, we are going to use Microsoft Word. So after doing it, we are going to see how we can convert it to a PDF and then we share to students or whosoever you want to share it. Alright, so I'm just going to crop this question and then I take it to the Microsoft Word software, and then we begin. So I've copied it already. So my Microsoft Word software is already open, so I already launched it, and here is a question. So for I'm just going to enlarge it so that we can see clearly. Then the first thing to do is that we are going to type the question, then we draw the diagram and we type the remaining part of the question. So let's go ahead with the typing, because I believe typing is also usually a problem. So generally, to make my work to be presentable, I always use the font name as Garamond. Here's a font name that I use, and to make it to be enlarged, I usually use a standard font size of 12. Sometimes I use 14 as well. So the question says that figure 2 below shows a particle A of mass m on a smooth horizontal plane connected by the means of a light inextensible string to another particle B, of mass 2m. Alright, so you can as well push the video in front if you want to just see how to draw the diagram already, because the typing maybe might not be a problem, which is on a rough plane inclined at an angle of 60 degrees to the horizontal. Alright, the coefficient, I'm just going to abbreviate it, of friction between our particle between B and the inclined plane is 0.2. Now the system is released from rest with the string taut. Alright, now time for drawing. Okay, so let me try to decrease the size of the image so we have enough space to draw. I'm just going to put this image on one side, and then we simply look at it and draw. So one thing is that we have to be very creative when doing things like this, because everything is here on the Microsoft Word software. So all we need to do is we just need to combine shapes that look like our figure, and then we draw the figure. That's all we have to do. Alright, so the first thing to do is that you just need to combine figures. Okay, and we can start with any figure you want to use, with any shape, with any shape. So let us begin by drawing our inclined plane, and then let us begin by drawing this trapezium here. That's the first thing to do. So I will just go to insert, and then I take shapes, and then now maybe I can just verify to see if I have a trapezium in any of my shapes. If I have it, then fine. If I don't have it, then I'm going to use lines to group it together. So do we have a trapezium? Let's see this. Maybe this can work. Can it really work? Let's see if it can work. Because that's the inclined plane there. Let's see something. Because for it to work, this thing was supposed to come right down. Anyways, this one cannot really work. So let us see if we have another shape that is a trapezium itself. Okay, then from there we can see if we are just going to, okay, let us try this. Even this one is not going to work. This one is not going to work as well. Alright, so what we are going to do is that we are going to draw it. Okay, so we first of all draw the horizontal ground. What I did was that I took, let me restart back. So I go to insert, I take shapes, then I take a line. I draw the line horizontally, but when you look at the line, it is not actually straight. Okay, so for me to adjust the length or the inclination of this line, I need to go close to the line. I double click on it, left, I left click 2 times, and then I'm going to have some informations about formatting the line. So here is simply the inclination of the line, so I've put it at 0. So you see the line is purely horizontal. Here is the length of the line. You can decrease it as well as you can increase it. Now I will need to make the line to be dark and a little bit bold. So these are the boldness and the texture color of the line. So I'll just make it to be bold. Let's decrease the boldness. Alright, I've drawn the horizontal. You can move it from one position to another. Okay, the next thing to do is let's now draw this vertical here, and then we later on draw the horizontal before we link them together. So I'm going to draw a vertical line as well. So beginning from here, I'm going to draw a vertical line. Now it is purely vertical. I give the same inclination texture, and then it is always good to group the figures together. That is always important, to group. How do we group? We come close to this line, we select it, and then we press a control button and we go close to this other line. If you don't press the control button and you go close to this line, this arrow with a little box below will not show. If I leave the control button, the arrow is not going to show. But when I press my control button and I go close to the line, the arrow is going to show. I click on the line to select it. When I've selected the two, I click on any of the figures. I don't click on the screen. If you click on the screen, you're not going to have the group option. So you need to click on any of the lines. You make sure that this arrow with 4 point, this pointer with 4 pointed arrow shows. You right click on it and then you take group, and then you group. Now you see you have grouped them. You can now move everything together. Now the next thing to do is that you now draw your horizontal. You pick from here, you draw your horizontal line. Now you always verify the inclination is 0 to show that it is either purely horizontal or purely vertical. We give it the same boldness, and then we group with this. We have this, and finally we now need to draw the slope. Okay, so we go to this and then we pick from here, and then we attach it to this, and then we bold as well, and then we group. We are done with drawing. That's the first thing to do. Now you see we can move this figure. Now what is left to do, we have the two masses which are simply boxes. So you just need to come and click on rectangle. You click on, or maybe you can click on something like this, a rectangle or whatsoever, you have it. And then now this is telling you how you can rotate. Okay, now you see you rotate it to suit your position, and then you can also as well decrease the size as well. Now we see that if you right click on or left, double left click on it, you have some options here, which is here is a filling to fill it to be dark. In fact, here are the different texture and the colors that you can put. Here is the outline, meaning that you see that as I'm changing, the outline is becoming the color that I'm selecting. Here it is dark, here it is white, here it is red, and so on and so forth. But since in our figure we don't want it to be filled, we take the dark outline, but for the filling we take no fill, and then we bring it closer and we place it directly on this slope. But we see that it is not directly, so we need to adjust the inclination and make sure that it falls directly on it. Doing that, remember that we always group so that we can move everything together. So we have group. Okay, now you can just copy the same, and then you put it horizontal and you place it here to call it your A, and then you group. To copy it, you just need to click here, and then you come to home and you click on copy, or use the shortcut Ctrl+C where you click on it, and then to paste it you come and just press paste, or you click Ctrl+V to paste. It all depends on you. Now I can move it together. Now I need to input A and B. That's the name of those masses, of those particles, A and B. So I go to text box, I click on text box, I draw the text box, and then I write inside the text box. Now if I just write A, you see it is not really good, so it is preferable that since it is mathematics, we put it inside an equation. So we go to insert, we click on equation, and then you see type equation. If you want to use the shortcut, you press ALT and then the equal to sign. Where you press ALT on your keyboard plus equal to, it takes you directly to it, and then you press your letter A. Now you see the text box also has to be formatted, because if I bring the text box to this line, it covers the line, meaning that the filling color there is white. You also see we don't need any outline, so we right click on it, we take fill and we choose no fill, we take outline and we choose no outline. We can now move it inside here, and then remember we always go, that is the rule that we use. Now from here we can now copy this, and then we put B there, then we come and put here as well. Alright, so we now group as well. Now what's the next thing to do? We need to impute the angle before doing the string and a pulley. So how do we go about the angle? There is a shape which I always use for my angles, and it is very good. We go to insert, we go to shapes, then we take on this arc. Okay, we draw the arc, and then we try to adjust it. You see, you can adjust the arc, you adjust it to resemble the angle representation in terms of shapes. So we move it, we bring it to where it is. Okay, and then it is good to make it a little bit, yeah, something like this. All we need to do is you just need to adjust it to suit what you want it to be. So we put this as well, and then we group. Alright, now we need to impute the 60 degrees there. So I just paste what I copied previously. I write 60 and then I put to the power, then I put my degree. That's the 60 degree. So either you put it inside or you put it outside. But to put it inside, you see that we need to shift this. Okay, we need to shift it so that so you just need to adjust it. Alright, so you have something like this. Now we need to shift and then this, let's make it to touch this line. We now take our 60-degree angle and we input it here. Okay, as well we can decrease the size and then we group. Alright, now we are left with the pulley and the string. So for the pulley, I'm simply going to put my small line here. I put my small line here. I put this. I group. Then I put a circle, right? We put a circle there to indicate the pulley, and then we put it. Maybe we can even put it like this, or in fact, let's just put it to be sorry, the outline should be dark. Let us put it to be no fill. Yes, no fill. And then we group with this, and then we are left with the line or the string. So the string, we just need to put a line. So just put a horizontal line that is linking both of them together, and then we can put we don't bold it too much to show that it is actually the string, not a line. We group, and then we also put it, we take it from here and then we attach it to this. Okay, and then we put this and then we group. Now we see that it's not really good like this, because we have to increase the size of this. Okay, so maybe we do something like this, or we could even make the circle to be smaller. It all depends on you. And then we can also increase this. Sorry, we increase this. We increase this shape. We increase this shape. Alright, so this is still A. You can even put it in bold, and this is B to indicate that those are the masses. We put it in bold and then we place there. We are done with it. Okay, now you see we can move it from one spot to another. Now we need to show that it is figure 2. So we take a text box, we draw the text box down, we write inside the text box figure 2, and then we adjust the text box. We format it by taking the fill color to be no fill and the outline to be no outline. We can also put it in bold. We can change the color, and then we can also put our favorite font size and font name, and then we put that figure 2, and then we group with this. Okay, finally we are done. We can now cancel this. So you see, this how we do to draw the diagrams and everything. Now what about maybe indicating the various forces acting in this system? It's the same thing. You just need to put your arrows and everything. So if we go to the mass, the particle A, we have the weight acting downwards. So we just go, we take the arrow, we draw it downwards, we adjust the inclination so it should be purely vertical, and then maybe you can even increase the boldness to show that that is a force. Okay, and then we can now also indicate that the mass of was M and then times G, so we have mg. That's it. Now remember, anything I do I group, so that I can easily move everything together. If you don't do that, you'll not be able to move the whole figure together. Now let us go to the tension here. The tension is always acting towards the pulley, so I take an arrow and I direct it towards the pulley, and then I make sure I bold it very well to indicate that it is a force. I group, and then I input, I call the tension, I call it T. So this is T. Now I also group. Anything I do I group, remember. Now also the tensional force here is acting towards the pulley, so I need to put it on the pulley, and then I try to also bold it, and then I group, and then I can just copy this T and paste, and then I bring it closer here, and then I group it with this. Now for the mass at for the particle B, we have the perpendicular component of the weight, which is perpendicular to the plane. It is the mass or the weight times cos theta. Okay, and the weight is 2 mg because the mass was 2m. So you have 2 mg cos 60, but cos 60 is half, so you can just say 2 mg on 2, which is mg. Okay, so we have mg, we group. Now the weight itself is acting downwards, vertically downwards, so we have the weight of it acting vertically downwards. We do this, we group, and the weight is 2 mg. So you just have 2, just attach a 2 here, you have 2 mg. Okay, now there is also a component of the weight that is acting parallel to the plane, and it always acts down the plane. So we have the component of the weight acting down the plane. In fact, it's preferable that we take anything from the center. So this is actually supposed to be from the center, and then this guy here also as well. So we need to adjust it from the center, so that we take this guy here from the center and put it like this. So this B here, we can put that this is B here, and then we group what we haven't grouped here. Alright, now we know that it is actually 2 mg sine theta, sine, which is sine 60, and sine 60 is root 3 divided by 2. The root 3, the 2 here is going to cancel, so we just have the square root of 3 times mg. That's a component along. Okay, now you see that it's now easy for us to resolve our forces, and also there was tension. And remember that the mass, which is the particle at B, the particle B will be pulling the particle A, meaning that we also need to indicate the direction of our acceleration. Okay, so I'm just going to use a big arrow to indicate the direction of acceleration. So let us use maybe this guy here, you see, and then we just do something like this. So we have that, we can just do something like this. We have that acceleration is in this direction. Okay, so that's the direction of acceleration. Acceleration is in this direction. So you can even leave it in that color to actually distinguish many things. So acceleration is in this direction. All right, now since acceleration is in this direction, and the inclined slope is rough, then the frictional force will be opposing the motion. So the frictional force will be acting directly on the inclined slope. You can put it there, put the force there. Maybe you can even put the color, the outline should be red to show that it's actually a different force. Okay, and then we say it is, the frictional force is F. Let's just say it is F. Now one force is lacking, which is a normal reaction at A and at B. So the normal reaction at A will be acting vertically upwards. So the normal reaction at A is acting vertically upwards. So we have something like that, and then we call it N. At B, sorry, even at A as well, you can also indicate it. So we have here the normal reaction at B, NB, because we have to write that frictional force F in terms of this normal reaction. So the frictional force F is actually the normal reaction times a coefficient of friction. So this is actually the normal reaction at B times the coefficient of friction. Let's say it is mu. It was even given as 0.2, so we have 0.2. Okay, but now clearly we know that the normal reaction is equal to the component of the weight that is perpendicular to the plane. You see, if you consider the system being in equilibrium, if you consider this axis, axis which is mg, you see that NB is equal to mg. So you can just remove it and replace it with mg. Okay, so that's our frictional force.